9.1 Triangle Basics. Okay, so a lot of the stuff we're covering today is review. So you've covered this before, just a reminder before we get into new stuff. So first off, let's talk about the angles of a triangle. So the angles of a triangle have to add up to give us 180 degrees, always. So if we know that, and if we're missing one of the angles, we can easily find what it is. Okay, so for example, A, we know that 76 plus 58 plus that missing side has got to add up to give us 180 degrees. Okay, so all we need to do is a little algebra to solve for x, and we're set to go. One way we could do is combine like terms first, or we could just subtract these over to the other side. So we'd end up getting x is equal to 180 minus 76 minus 58. And we would use our calculator, and I think we end up getting 46. Perfect. Okay, as easy as pie. All right, now we look at B. It's a little different, but it's basically the same. So we need to add those three angles. Make sure we read the instructions. They want us to find the measure. That's what the M stands for, is the measure of angle A. So we want to find what this is. We don't want to, we need to find out what X is first to find what that angle is, but we're not solely solving for X. So keep that in mind. We do 70 plus x plus 56 plus x plus 66. That's got to give us 180. I think it's a great idea to combine like terms. That gives us 190, 92. And then we could combine the x's. That gives us plus 2x equals 180. And again, we do some algebra to get x by itself. So subtract 192 from both sides. And then we'll divide both sides by 2. And we get x is equal to -6. So again, that's not what we're solving for. We'll need to substitute that in for x to give us our angle. So the measure of angle A is equal to -6 plus 66, which is 60 degrees. All right. One other thing I didn't mention, and just a reminder too, is this. If we have a right angle, I just want to make sure everyone's got this, that's 90 degrees. So if we ever have a problem on a homework or a test, and we have this right angle, that value is 90 degrees. So maybe that's 30 degrees, and we need to find this missing side, would end up getting 60. Okay? All right. Isosceles triangles. Okay? So I meant to write that down in advance, but we'll just do it right now, I guess. So we'll write this down. There we go. Okay, so properties of an isosceles triangle. Okay, if two sides of a triangle are congruent, and again, congruent, that means like equal to, then the angles opposite those sides are congruent. Okay, so it's basically saying that let me switch back to my pencil. Okay, so basically saying that if we have two congruent sides, then we also have two congruent angles that are opposite of those congruent sides, okay? So we'll never use, these two will never be the same. These two will never be the same. It's always the ones that aren't touching those two congruent sides, if that makes sense. Okay? Then let's talk about equilateral triangles. So if we have an equilateral triangle, maybe I'll just write it the same. Okay, if we have three equilateral triangles, that means we have three congruent sides, and we also have three congruent angles. Okay, so you could write that down. If we have an equilateral triangle, then we have three congruent sides and three congruent angles. All right, and these angles, since they have to add up to 180 degrees, these have each all got to be 60 degrees. All right, so using that information, we can also find some missing angles that if we didn't know that they were equilateral or isosceles, then we wouldn't be able to find this information. So pause and give a try on any of these if you'd like. You'll learn best if you will do that. All right, so again, this is an equilateral triangle, which means that all the angles have got to be the same, which means that x has got to be 60 degrees. This is an isosceles triangle, which means the angles opposite of those sides have also both have to be the same. So that means that this angle has also have to be x. So we know the angles add up to 180, so we can do 30 plus x has got to give us 180 degrees. That gives us 30 plus 2x equals 180 degrees, and then we can solve for x. So subtract 30, that gives us 2x is equal to 150, and then just divide both sides by 2, and we end up getting x equals 75 degrees. All right, C is a little different too, but it's an isosceles, so we know that these two angles are the same. So this has got to be 46, because those are the angles that are opposite of those sides, congruent sides. So 46 plus x has got to give us 180 degrees. We could combine like terms, or we could just do x is equal to, we could just subtract 46 from both sides. And we just end up getting 180 minus 46 minus 46. Looks like that gives us x is equal to 88 degrees. There's not percent, degrees. Okay? All right, so here's some other examples. Feel free to pause. If you feel like you've got it, let me know, or skip, but make sure you understand how to do all three of these. So again, this is isosceles, so we know that the opposite sides are also congruent. So this has got to be 11. Again, this is the measure of angle 2. That's this angle they want us to find. We know that this is an equilateral because all three sides are congruent, which means that all three angles have got to be 60 degrees. And then here, again, we know that these two sides have got to be congruent or equal, and we just solve. So we could add 7 to both sides. Again, it's the opposite of PEMDAS. So, or we talked about in a previous unit that it's kind of like an onion. We need to take what's least attached to x. So we would add 7. That gives you 16 equals 2x, and then we divide both sides by 2. And yeah, there we go. Okay, any questions, let me know. Let's go talk about the triangle inequality conjecture. This basically says that if we add two sides of like a triangle, it has to be greater than the third side. Okay, a shortcut for that, what we really need to do is we need to add the two smallest sides, and that has to be greater than the third side. And why? Let's kind of look at a little situation. Say we have a side here that's maybe 11, and then we have another side here that's maybe 6. I guess maybe we'll make it a little longer. And then our third side is 5. Okay, so if the two smallest sides were the same length as the third side, then it would lay flat. It wouldn't have any area. Okay, the two smallest sides have got to be greater than the third side for it to give us a triangle. So like for another way we could draw this is, if we had these really short sides, I mean, obviously that's not going to make a triangle. It needs to be, the two smallest sides have got to be greater, the sum of the two smallest sides have got to be greater than the third side. So this is like the largest side, and these are the two smallest. Okay? So let's do a couple examples and see if that makes sense. I always like to do an example in class where I kind of take my arm straight out, okay, and we'll say that and you could do this, try and do this right now. Put your arms all the way out, okay, and then just bend your elbows, okay. These two, like your forearms and your hands, if you try and move them close to yourself, like towards your head, they'll never make a triangle. They'll never meet because your forearms aren't long enough. So the two smallest sides of the triangle have to be greater than, the length between your two elbows, if that makes sense, okay? If you want to see an actual visual, then email me, and we can do a Google Meet and I could show you, okay? Another way, there's some great ideas on online that kind of explain it using triangles and stuff like that. So, all right, so let's answer these questions. It says, state whether the given three numbers could measure the sides of a triangle. Justify your answer. So when I say justify, I'll tell you how we do that. So we need to find our two smallest sides. That's 4 and 10. We add those together. That gives us 14. Okay. And is 14 greater than 12? We'd say yes, so it can make a triangle. Okay, and this is how I want you to justify. I don't want just a yes or a no. I want you to justify using inequalities. Okay, so 14 is greater than 12, so we can make a triangle. Let's try B together. So the two smallest, that gives us the 12 and the 8. We add those together. That gives us 20. Is 20 greater than 22? No. So it cannot make a triangle. Okay, it would look something like this if we had the 22. We would have the 14 here, and we would have the 8 like this, and there would be this gap where we wouldn't even be able to have them touch. All right, pause and see if you can do the last 4, see if you can come up with. All right, so 2 smallest, that gives you 16, which is not greater than 17, so we would say no. We could do 11 plus 7, that's 17 is greater than 19. That is also no. Okay, or so that's 18. So that's still no. And we could do 9 plus 3. Well, that's 12. Is 12 greater than 12? No. Okay. That's a lot of no's. Am I doing this all right? I think I'm okay. Okay, and then last but not least, we have 4 and 6. That gives you 10. And 10 is greater than 9, so we would say yes. That can make a triangle. All right. Next we have is called the side angle inequality conjecture. This basically tells us that there's a relationship with the an angle and its opposite side. So if we were to look at this, I just put these numbers in. They don't really mean a whole lot except numbers, okay? But they kind of look like they could possibly work. So if we look at this, which angle seems to be the smallest? And to me, I would say that this angle probably is the smallest angle. And which side is the smallest side? Well, it would be the 4. So there is a relationship between the smallest angle and the smallest side. Let's look at the largest angle. To me, this looks like this is the largest angle. And let's also look at the largest side. Well, that would be the 11. So again, we have this relationship between the largest angle and the largest side. So this is what this conjecture says, is that the shortest side of a triangle is always opposite the smallest angle. And the largest side of a triangle is always opposite of the largest angle. Okay? So with that information, let's order the sides of each triangle from shortest to largest. So make sure you do that. It would be sad if you did it backwards and lost points for that. So we'd look for the smallest angle. It looks like the smallest angle is 53. So again, the smallest side is always opposite of the smallest angle. So we come out of that, and the opposite side would be UT. So that is the smallest side, or the shortest side, okay? And then we'd go to the next. The next largest would be the 60. So opposite of that is the next smallest side. So that would be ST. It doesn't really matter if you do like UT or TU or ST versus TS. Typically we do alphabetical, so just do that if you can. And then we have our largest angle is opposite the largest side, so that we'd do something like SU. Okay, and that's it. We put a line on top of it telling us that it's a side, so make sure you do that too. All right, here's just some other examples. You're welcome to pause and give this a try. So here we have a 50, and we also have a 50, which means that their opposite sides are also congruent. So this is an isosceles triangle, which means that we have side KL is KM are the same. So you could use like and, or you could do like an equal sign saying that they're congruent, which is probably what I would do. And then our largest would be opposite of the 80. So that's like the LM. Okay? I think this is how your answers will write those, like your answer key. But also we could also just say like equal. All right. Here's just a couple more examples. So here's the smallest. We'll do LK. Next we have the next smallest is LM. And then the largest is MK or KM. Either way, we're good. Okay, another isosceles. So we have these congruent angles, which means their opposite sides are also congruent. So GE is equal to FE. And then we have the largest side, that is the largest. I guess I did that wrong. So this is the smallest, so I need to put that in front. So GF. Okay. All right. And we can also do it in the opposite direction. If we know the sides, we can find, the smallest to largest angles. So this is the smallest side. Then opposite of that is the smallest angle, so angle D. And then we have 18. Opposite of that is angle E. and then opposite of the 19 is the angle F. So pause and give these two a try. Smallest is angle A, then the 22 is the angle B, and then we have the angle C. Here we have, looks like 10 is angle R, and then 16, angle S, and I think this is a 19. Gives us angle T. And again, we could have an isosceles triangle, and if we did, we'd end up having, like, we'd set them equal to each other if they were the same. All right, last but not least, we need to talk a little bit about angles, specifically parallel lines that are cut by a transversal. So typically, if you have like parallel lines, we use these little triangles to tell us that they are parallel. And then this is called a transversal. It's a line that cuts through two parallel lines. Okay? So when we get into future lessons, we're going to need to know these kind of rules, especially the ones that have stars. Okay? So keep those in mind. Those are probably the most important. The others are also important, but not as important. All right, first off we have is vertical angles. So vertical angles are angles that are vertical, like on top of each other. So they're opposite of two lines, so something like that. These are vertical angles, okay? And vertical angles are congruent. Okay, they're the same. Okay, so that's one example. We could do another example here and here. Those would also be vertical angles, or 5 and 7, or we could also do 6 and 8. Those are all vertical angles. We also have alternate interior angles. So alternate meaning that they're not on the same side. So something like this, these two, those would not be alternate. The two green ones, those are alternate because they're on the opposite side of, like that transversal. And then they're also interior, which means the two angles are both inside of those parallel lines. Okay? Alternate interior angles are also congruent. Okay? They're equal to each other. Next we have alternate exterior angles. So they are opposite sides of the transversal, but they are not inside, they're not interior, they're exterior. Okay? So those are also congruent. Okay? Next we have corresponding angles. Okay? So basically they're also congruent. A lot of these are congruent. So we just need to know that if we're given two parallel lines, then we can say a lot of stuff about two of the angles, whether they be congruent, they're the same or not. Okay? So corresponding angles, they're basically, like those are congruent angles, or corresponding angles. 3 and 7 are corresponding angles. 2 and 6 are corresponding angles, and 4 and 8 are also corresponding angles. Okay, and it kind of makes it makes sense, right? It kind of makes sense that if these have the same, if they're parallel and they're cut through the same angle, these two have got to be the same. All right, and then the last two are adjacent angles. So adjacent angles are supplementary. Supplementary, and I think I spelled that wrong. Supplementary. That sounds really bad. I'm sorry if I spelled that wrong. Supplementary meaning that they add up to give us 180 degrees, which would kind of make sense, right? This angle plus this angle gives us 180. If it goes all the way around, then it's 360. So I think that kind of is a little intuitive. Supplementary. Man, that's driving me crazy. All right, and then here we also have same side interior angles. So versus where we did alternate interior angles, we have same side, okay? And these two angles also add up to give us 180 degrees supplementary. All right, so using that information, we can kind of answer some of these questions. So these say what type of angles they are, and then we'll solve for x. So first off, we can say that these are vertical angles. And then if they are, we know that they are congruent. They're the same. So 10x is equal to 9x plus 8. And we could solve. We could subtract 9x from both sides, and we end up getting x equals 8. Okay, here's another example. These are alternate. They're not on the same side, and they're interior. But again, they are congruent. So we know that 6x minus 5 is equal to 5x plus 5. So we could subtract 5x from both sides. And that leaves us with x. And we can also add 5 to both sides. And we get x is equal to 10. And we could plug that 10 in if we wanted to, and we'd end up getting 50 plus 5 is 55. And this would give us 60 minus 5, which is also 55. So you can always plug those in and make sure that they're right. Okay, just a couple last examples. So these are same side interior angles, which means that they add up to the same, or they add up to 180. I mean, this angle is the same as this angle, if that helps. Well, we just add them together and they have to give us 180. So x plus 81 plus x plus 111 is equal to 180. And then we could, that gives us 2x plus, what's that, 192. And then we'd subtract 192. Gives us negative 16. And we could divide both sides by 2 and get x equals negative 8. Okay, and again, we could plug those in and they should add up. Both of those two angles should add up to 180. And then last but not least, these are also same, is that what those other ones are? I always get those up. Adjacent angles. I always get those mixed up. So adjacent angles, again, those add up to give us 180 degrees. So 6x plus 8 plus 17x plus 11 have got to give us 180. And we do the same deal. What that give us? 23x. When we combine those, plus 19 is equal to 180. 180 minus 19 gives us 23x is equal to 161, and then divide both sides by 23, and you get x equals 7. All right, so that's it. Sorry, that took a bit, but hopefully these are just like little things, these basics that you've covered before. Just hopefully this comes to you kind of quick. All right, we'll see you later.